Hello, and welcome to my quick little non-binary subnetting thing. Um, I'm going to give a little history on how I came to this. I'll put a marker up there if you just want to jump straight to the time. But I've been doing IT work since early 90s. 90 actually. My first computer I got back like in the mid 80s. I never really did much with networking, and when I retired from the military, I got a job and a knock, and I needed to get my CCNA, so I had to learn subnetting. And I just could not get that whole bit flip crap working in my head. It just made no sense to me. And I was getting frustrated. Now, granted, I only gave it like 3 days, and then I stumbled across this, and I never bothered after that because this is too damn easy. Uh, but anyway, and just so you know, I'm not saying that I'm the only person that's ever done this, but for me, I've never seen anybody else do it this way. Everybody I've ever shown this has never seen it done this way, but it works. And I'm going to start out with Class C's because this is where I started. And then it's slightly different for Class B's, but I'll show you that towards the end. But it's so simple. It's literally, instead of doing all that binary bit flipping crap, this is just simple division. As long as you understand this table, and I've got this actually worked down to a /16, you can carry it further if you want to later on. As long as you understand that table and what it means and how it works, then you can do this. For example, when I took my CCNA, before I even took the test, I took one of those scratch pieces of paper and I drew this table out. I drew this all the way down to /16. I could add on to it if I needed to, but I didn't really need to. Um, but as long as you understand this and how this correlates with this and with that, how the CIDR notation correlates to the number of addresses and how many subnets that is for a Class C. And of course, you do want to know what the subnet mask is, but I mean, once again, it's a power of 2 if you look at it. Because all you got to do really is 256, you cut it in half, you get 128. Cut it in half again, and then add on to that. So 64 to 128 gives you 192. Cut 64 in half, go up again. That's 32 added to 192 is 224. Add 16, you get 240. Add 8, you got 248. Add 4, 252. As long as you know how to do this, okay, and when it comes to going the opposite direction, you start with 254 because 255 here and go down that way. All right. As long as you understand how to do that, you can draw this table. Then from here, you can subnet using division, simple division at that, in seconds, as opposed to flipping bits and doing this, that, all of the crap. Fuck. Anyway, so let's go ahead and show you what I mean. And by the way, the guy that was showing me this, it had taken him a couple months to get the binary stuff down. His name was Antoine. He's a great guy. And when I was standing at the whiteboard, I couldn't get it, and this hit me. I gave him the network ID by using my this little thing, and he goes, "Well, that's not going to work for everything." I said, "Give me another one." And he gave me like 4 or 5 Class C's, and I got every one of them right. And then he said, "Well, it won't work on a Class B," and I was like, "Yeah, it will." So he threw a couple of those at me, and it worked, and he got mad and went out and started smoking. And he wasn't mad at me. He was mad because it took him a couple months to get this whole binary crap down. And I sat there at the board, and I figured out a way to do it where it doesn't take any of the binary at all. You just have to know how to divide. So anyway, let's get back to this. So let's take an example, and let's do this as a /28. And what's a good number? We'll make it 209. All right. So if we got an IP address of 192.168.0.29, 209, excuse me, on a /28 network, what's the network ID? What is the network ID? Well, I can tell you right now. I think Let's see. Let's go 209. I think it's 13. If it's 13, it's going to be, yeah. All right. So 209 divided by 30. Nope. 16. By 16. Yep. 13. All right. So 13 is the max number of times that 16 IPs can go into 209. All right. So what does that mean for this? Well, it just means you go 16 times 13 and you get your network ID, which is going to be 208. Simple, right? Now, 209 being the first IP on there, that's why there was that remainder. Now, what do I mean by how is this simple division? Well, oops, let's draw this out. I'll show you what I mean. So, doing this out long style, you take 209, right? And you divide that by 16. Now 16 goes into 20 one times. Take that 16, which is really, remember, 160. We need to keep this number. Oops. Sorry, my pen broke, so I'm having to use my mouse, and it's really not that nice. Anyway, 160 over here, right? So what does that leave us left over? It leaves us 49 left over. Right? Now 16 can go into 49. So we do it again. It can go in there 3 times, which gives us 48. Which leaves us with 1 here. 16 cannot go into 1. Okay? So we stop. This is where we stop. Now we take this 48, we bring that over here. Oh, give me an arrow. Right? And you add these two together. Gives us 208. With 209 being the first IP on the 208 network. 13 times 16 gives us 208. 160 and 48 gives us 208. This remainder is where your IP is on that network. Did I lose you? Let's try another one. All right, let's try a different one. Clear, clear, clear. All right, so let's say we've got a let's do a 27. Okay, and let's change this to 119. So what's our network ID going to be here? Any guesses? I can tell you what I know. I already know what it is. All right, it's going to be 96. I just do this that often, but let's verify that, okay? So on a /27, you've got 8 subnets of 32 IP addresses. So we're going to take 119, and we're going to divide that by this number here, 32, since we're doing a /27, excuse me. All right, so divide that by 32, and we get 3 with a whole bunch of leftover remainders. Well, what's 3 times 32? 96. So there's your network ID. Look at the math way. So we take 119, 119, divide that by 32. Can't go into 11, so it can only go into here. If we do 4 times, that's going to be 128. That's not going to work. 3 times though, so 2 times 3 is 6. 3 times 3 is 9. That's going to be 3 here. It's 23. 32 can't go into 23, so this has to be our network ID. And this is the 23rd IP on the 96 network. Does that make sense? Let's try it again. Whoops, cancel. New. All right. Let's try it again. Let's do a, well, let's go do a /29. And let's make this 243. How does that sound? Alright, so slash 29 has 8 IPs, right? 32 subnets. I already tell you it's going to be 240, but let's go take a look at it. Alright, so we bring, oh, I'll close my calculator. How nice. Alright, so let's go 243 divided by 8 equals 30. Clear that. 30 times 8 equals 240. Yeah, see, I was right. You see how you can start doing this in your head once you understand how to do this? Subnetting becomes easy. You have to shift your perspective. That's all it is. Alright, so let's look at it, do the math way. Let's go back to Paint again. And we'll do 243. Right? And since it's a 29, we're dividing by 8. So 3 times 8 is 24, which is really, remember, 240. So we keep the 240. Alright? Leaves us 3 left over. And since 8 can't go into 3, that's the third IP on the 240 network. We're done. Alright? And once you know this, I mean, you can look at it and say, okay, so let's make this a slash 28. What's that going to be now? That's going to be a 232 network. Why? Because you just increased it by 16, so all you got to do is subtract 8 from 240 to 232. Right? What if it's a slash 27? Subtract 32 from 240. We're back to 208. Subtract 64 from 240. What do we got? That's a good question. What do we got? 64 from 240. That's 176. Is that right? I don't know. Let's go check it. That doesn't sound right to me. Doesn't sound right. The others make sense. That one didn't. So let's make that. Let's go take a look at it. So if this is a slash 26, right? So it's 64 goes into 243. 243 divided by 64 3 times. So clear 64 times 3 is 192. Okay. Yeah, that does make sense because you can't. That was my fault. I was thinking wrong. Anyway, you get what I'm saying. And then from 192 to break the network down. Oh, I see. I was operating off the IPs. To break it down even further, on 125 slash 25, it's got to be 128. You see how that goes? Let's try another one. See, even I can get confused doing this crap, and I've been doing it for a while, but that's why this is so much. It's a lot easier to check than the other stuff. Hell of a lot easier. What if it's an 88 IP and you're on a slash 28 again? Okay. One more time. I close the calculator again. I gotta stop doing that. Alright, so 88 divided by slash 2816. It's 5 with 5 left over. 0.5, well, there's a remainder. It's not necessarily 5. Alright, so clear that. 5 times 16 equals 80. So the network ID on this is going to be 80.
What should I remove?
Alexa, stop. I don't even know why she came up. Alright, but there's your network ID. Go look at it and do the math again. I closed the paint too. I'm doing real good here. So we look at 88 divided by 16. It said it was 5, so 5 times 6 is 30. gives us 80. 16 can't go into 8. So it is the 8th IP off the 80 network. Easy. Now, that's all working on this 4th octet. Well, when you start getting into Class Bs, you can't do that. So let's take a look at what a Class B would be. Now, I stood there for a few minutes when he started throwing the Class Bs at me, and I got to thinking, well, it's a power of 2 again, but if it's power of 2, that means that this is just doubling every time, right? So how does that work? Well, you just ignore the 4th octet because you don't need to worry about that. So let's go, we'll do a /22. Let's do a IP address of, I don't know, let's make it 19.88. All right. So what's the network ID on this? So if it's /22, that means that there's 4 Class C IP addresses in each one of these. Well, that tells me right now that the network ID is going to be 16.0. Why? How many Class Cs can go into this network? Okay. Into this cleanly. This one right here. 4 goes into 19 4 times. 4 times 4 is 16. There's your network ID. That's it. I'm done. Because the next network ID is going to be .20. If this was a /23, okay, the network ID would flip up to 18 because there's only 2 Class Cs in each one. All right, see this? 19 divided by 2, you get 18 before it can't go in there any cleaner. 9 times. So 18 would be your network ID. All right, if it was going to be a /19, let's go ahead and go big time. 19, the network ID on this is going to be 0.0 because the next network ID would have to be, let's get over here, .32. You see how that works? So 192.168 dot, I don't know, let's do 207. Okay, where's that set on a /19? Well, bring up the calculator again. 207 divided by 32 6 times. Oh crap. And then 6 times 32, 192. So the network ID on that, actually this should be up here, that's my fault. So what's the network ID for this? 192.0. And I mean, once you see this, it's hard not to understand it. Now I'm just throwing this video together real quick, and I'll probably do a better one later. But I mean, the Class C's are easier than the Class. I mean, the Class B's are easier than the Class C's as far as I'm concerned, because you're just working off of, you know, the 3rd octet, and it's just a power of 2. That's all it is. You know, once you understand, if you've got this table where you can draw it out and you can memorize, and all you have to do is remember, you know, your Class C is a basis for both of these methods of doing this. It's just simple division. How many Class C networks can go into a /17? 128 of them. All right. So it's just easy to do until you get to here where you're done. See what I mean? This now, I'm not saying this will work down. I never really had to take it any further than this. Not really. Um, but this is the way it works. I mean, it couldn't be any different, really. If you start looking, I mean, the subnet mask doesn't change, right? But this is how I was able to get past my CCNA in like no time flat. Because I mean, they stuck pretty much somewhere in here for the big questions and somewhere in here for the little ones. You know, they weren't trying to take you down into the class A's at all. They weren't trying to get much past 16. But if you can keep this information in your head, it's just that easy. Well, here, let's do another one real quick, so that you can understand once again. So let's say we've got a network. Let's go IP address of 192. I don't know, 250. All right. Oops. And it's a, I don't know. Make it a 21. Okay. It's a 21, so that means 8. Right? So what's the network ID on this? And yeah, I got a cat over here that just will not leave me alone. So let's do the math. 192 divided by 8 equals 24. Guess what? The network ID on that one is going to be 192.0. That's just happened to be that one. If we change this to, let's say 167. 167 divided by 8 is 20.8, so we'll clear that. 8 times 20 is going to give us 160. So the network address on this would be, oops, this should have been 167 up here. So the network IG on this is going to be 160. It's just that easy. Use this table. On the third octet, you're looking here. You just want to divide by this number. You want to divide the third octet by this number here, if that's what you're working with over here. On a class C, you want to divide the fourth octet by that number. I'll write it out. If subnetting class C, divide the fourth octet by the total number of addresses available to get the network ID. If subnetting a class B, divide the third octet by the total number of class C, and I'm going to capitalize that, networks broken into. Okay. Once again, if subnetting a class C, divide the fourth octet, this one here, by the total number of addresses available to get the network ID. That's this column here. Alright. If subnetting a class B, divide the third octet, this one here, by the total number of Class C networks that the Class B can be broken into. That's how many times you can get a Class C network out of a Class B. Okay? And as you can tell here, 250, it's powers of 2 again, it just doubles. I've always figured it sticks of RAM or, gigabytes, however you want to look at it. But /23 is 512 total addresses available, 510 usable, 1024, 248. You guys know these numbers. If you've worked with memory, disk space, disk storage, whatever, these numbers are something that you see all the time. Whether you're working with RAM, whether you're working with disk space, whether you're working with, the recycle bin and how much storage you want to give that, or the numbers of gigs that you've got out there. There's your standard gigabyte right there, 1024. This works. So let me know what you think. I'm probably going to do a cleaner video of this at a later date, but I figured I'd throw this out there for, people that need it. Good luck on your CCNA or your Network Plus. Once again, I've mostly seen these for like Security Plus, Network Plus, CCNA, and somewhere in this range. I've never seen them go really down below, /16. So, all right, good luck, and let me know what you think.